Inclined planes. Okay, we're going to do the first kind, that's that first situation. Inclined plane, we're going to be looking for the components, and we're going to remember that this thing is going to be undergoing no acceleration. So either not moving down the inclined plane at all, or moving down with a constant velocity. So we'll draw ourselves out our general picture of inclined plane. So there's our general picture. You're going to have an object on that inclined plane. I'm going to tell you that this thing is 125 kilograms. And I'm going to tell you that this thing is 28 degrees. And we are going to find a whole bunch of things. We're going to find Fx, we're going to find Fy, we're going to find force of friction, and we're going to find Fn. That's going to be like our first thing. And our second thing is we're going to try to find the coefficient of friction. Okay, so when we're finding all 5 of these things, I'm going to show you all sorts of tricks, things that you'll remember, which will make inclined plane much easier, I hope. So, let's draw in everything that we need here. Force due to gravity is pulling this down. You're going to have a y component of the force, that's going to be Fy. You're going to have an Fx right here. And this will be 28 right there, if you can see that. So, first thing I would suggest you do, and I only suggest you do this right now for the very first one, is let's redraw this right triangle in a way that's easier to see. So let's see, that would be like that, I think, right? Yeah. So that's going to be Fy, Fx, Fg, and this here is 28 degrees. That's your right triangle. Now, what we can do is use this right triangle to find Fx, Fy, and then make our general situation for inclined planes, which isn't going to be the same as all our other general situation. So our second thing that we're going to do is we're going to find our Fx. So find Fx and Fy. So Fx, let's see here, Fx is here. You have your theta, it's opposite, so that's going to be sine. So let's say that sine of theta, which is 28 degrees, is going to be my opposite, Fx, over my hypotenuse, which is Fg. So there's your statement. I want to find Fx. So Fx is going to be Fg sine 28. And actually, I could almost, because I see this here, I might as well go up and I'll write my general situation for Fx. It's going to be Fg sine of theta. Okay, I'm just keeping that up there because I have space. I'm still filling this thing in. Fg is 125 kilograms times 10, so that's 1250 newtons times the sine of 28. So Fx is, what is Fx? 586.8 newtons. Okay, I'm gonna fill Fy in right here. Fy. That's gonna be Fy. That's adjacent, so that's gonna be cosine of theta. So let's see here. Cosine of 28 is gonna be Fy over Fg. So Fy is Fg cosine of 28. I'm going to go back over here. Fy is Fg cosine of 28, or theta. That is your short form. You don't have to do any right triangles. Just remember that. For inclined plane, that sine is against x and cosine is against y, and you're fine. So Fy is 1250 cosine of 28, which means your Fy will be 1103.7 newtons. There. Kind of stuffed it into the edge, but now I have lots of space on this piece of paper. So there's your two components. So this one is 586.8 newtons, and this one is 1103.7 newtons. So you have your two components. Now what we want to do, so I've done this, and I've done that. I want to find FF and FN. So that's going to be my third step. Find FF and FN. Alright, well, let's see here. The thing is moving with no acceleration, which means that if I take my force in the x direction and I put it into a place where we can actually see what it's doing, it's actually pulling the 125 down this way. This force has to balance off against your force of friction. If your force of friction is equal to your Fx, then that's pretty easy. I can just make that as a statement. Force of friction equals Fx equals 586.8 newtons. That's only when we have constant velocity. Okay, then Ff is equal to, or Fx is equal to Ff. Okay. If my Fy is pulling down, my normal force has to be pushing up. So there's Fn. So Fn is equal to Fy, which is equal to 1103.7 newtons. Okay, so there. Now we have our two forces, and the third step is pretty straightforward. We're just saying that Ff equals to Fx and Fn equals to Fy. Fourth and last step, we want to find our coefficient of friction. And this is going to be a pretty good little trick for you. I'm going to show you. So I know that my force of friction is equal to mu Fn. So then my coefficient of friction is just going to be force of friction divided by Fn, which is really just saying Fx over Fy. I'll plug those in. Fx is 586.8 over 1103.7. So your coefficient of friction, when you plug that into your calculator, you end up getting 0.53. Square that off. Okay, now, how look at this? Fx over Fy. I'm going to rewrite this here. Fx over Fy. Well, go up to your little tricks here. Fx and Fy, Fg sine theta, Fg cos theta. Remember that. Fx is Fg sine theta, and Fy is Fg cosine of theta. Well, your Fg's cancel, and what you're left with the sine over cosine, so your coefficient of friction ends up being equal to tangent of theta. So there is even a shorter form than all this work. If you're asked to find the coefficient of friction here, your coefficient of friction in this case is just going to be tangent of 28. And check it out. Do it on your calculator. It should equal 0.53. So that is your trick. Those are your two components. You have got a lot of work for just a simple component question on inclined plane. There you go.